All right, so it's a graphing test. It's all about graphing. So if I were to ask you to do something like this, y equals absolute value of x minus 4 plus 7, you just have to absolutely know what the absolute value function is, right? Absolutely know what the absolute value is. It's a V shape, and then you go move it where? Right 4, and then up 7. Here's the one that really confuses people, though. I throw in a 2 right there, and now it's 2 times what? It's not really. What is it? It's half as what? Half as wide. Okay, so don't get confused on that one and think, oh, twice as wide. That's the instinct everybody has, and it's wrong. All right, so it's half as wide, and it's been moved 4 to the right and up 7. All right, make a little sketch of that. Just take a quick sketch. And then I want you to make some points for me that you know would be on it. You know how you can make an XY chart, make sure you're doing it right? This is going to be super helpful tomorrow. You're going to want to check your answers by making a little chart like that. All right, so I get that it's a V shape, and it's been made half as wide. All right, what does that mean? Well, that means like this distance right here. So normally 1, 2, 3, 4, 5 should be half that, should be 2.5. So it should go like to there. So it's narrower than it used to be. All right, and it's also got to be moved to the right 4 and then up 7. So this narrower V, move the whole graph. What? It's got to be narrower V. And now it's got to be, undo. So now it's just got to be moved right 4 and up 7. And now, how do you know for sure if you're right? Well, how many of you had it generally there? Okay, that tells me I'm probably right, but you can't do that on the test, right? You can do this, though. You can say, okay, it looks to me like it's like over 4, and I go up some. So I'm going to stick in 4, and I see what happens. Do this. Stick it in. Figure out what you get. You can do that one really easy, because it's 4 minus 4 is 0, 0 times 2 is 0, and then plus 7, it's just 7, right? You get that? If I stick in a 4 right here, 4 times 2 is 8. Oh, sorry. 4 minus 4 is 0, and then 0 times 2 is 0, and then I add 7 to 7. Is 4 comma 7 on my graph? Over 4, up 1, 2, 3, 4, 5, 6, 7. Yes, it is. See, I did it right. Would I check just one point? Probably check a couple. Okay, now maybe I should check one more point. So I'm going to go over 5 instead of 4. And if I put in a 5 right here, I'll have 5 minus 4 would be 1. 1 times 2 is 2. 2 plus 7 is 9. And I should have 5 comma 9 on my graph. Over 4, over 5, up 7, 8, 9. And, well, I was off a little bit there. So I can see, well, maybe I should just be more careful with my graph. You know. So I was off a smidge. And this one would be right there. So it's off just a touch. But okay? All right. So do you get how you can use this thing to check? Raise your hand if you get that part. Okay, good, because that's really, really important. Because all these are graphs. You can use that a lot. Yes. You will have graph paper on the test. All right. Next, and this is really important. I haven't talked about this one much at all. You have to do these functions that are like a squiggle. Actually, let me pull up a piece of graph paper to make it cleaner than that. So 1 second here. There. Okay. Also need something else from over here. That. That. All right. And remember, if they give you a function that kind of looks like that, and then they ask you to do something with it, like stretch it, move it, flip it, okay? Those are pretty easy. Let's say I just had to take, this is f of x, and I had to do f of 2x. What did they just ask me to do that? Make it what? Wider, narrower, taller, skinnier? What? half as what? Wide. Okay, if I got to go half as wide, it used to be 3 wide. Now it's going to be 1.5 wide right here. You know what I mean? That point right there needs to suck into there. So now, and the height stays the same. See how it starts? Now this point right here, how wide was that? It used to be 2 wide. Now I want it to be half that wide, so it's going to be right here. And then it used to go over 1, 2, 3.5, so half of that, that's not looking. Half of 3.5 is 1.6 about, so that'd be here. So that tells me to go like that. See how the red one is half as wide as the blue one? Do you think you can handle that? Okay, that should be, that's kind of the easy stuff. So you're seeing most people feeling like they get that. Now here's the hard part. What if they ask you to take the absolute value of this function? It's not that hard, but you will want to take notes on this. There's 2 ways they can do the absolute value. They can do the absolute value of the whole function, like this. I'm going to do this in black. F of x, but with absolute values around it, the whole thing. Or they can take, and I'll do this one in green, they can take just the f and put absolute values on just the x, like that. You get how there's 2 different ways to put the absolute values in. You want to write these down. You are going to be tested on this. All right. Now, have you heard before that f of x is like y? So do you get that when they do the absolute value of f of x, like this part right here, that they're really doing the absolute values of the y's? When you do an absolute value to something, do you get that all the negatives go away? So what you do on this kind of a problem is you find all the places where y is negative and you make it go away. Now if I make this box, you just like, I'll make this box better. I can use front border, percent front, that way it'll block, and there we go. See? That's almost done, but it's not done yet. The first thing you do is you hack out all the places where y was negative. Get them out of there. You erase them. Then, does it really make it disappear? No. It makes whatever was negative become what? Positive. So whatever was down there needs to move up here, up to above the line. So I got to go and look at what did I have down there. And whatever it is, it needs to now move above the line. So the part that was below the line has just moved above the line. And the part that was below the line is gone. And there's my final answer. I'll just make it in black completely. There would be the final answer. I took what was below the line, the stuff where y was negative, and I changed it over to be positive, because that's what absolute valuing something does. So this is like y, and I just absolute valued all the y's, which made all the negative ones turn positive, which made them jump from the bottom down here up there above the line. Yes? Yep. Yep. It reflects up over the x-axis. That's correct. All right. And the other parts that were already positive, they stay the same. Now, I bet you that this is going to make sense to you. So now look at the green one. If I just absolute value the x's, do you get that the x's that were negative have to disappear? Just like the y's that were negative have to disappear. The x's that were negative have to disappear. Do you get that I'm covering up the things where the x's were negative? So that's your first step. Okay. And then the second step on that is, remember that those things, this one's a little harder to explain why this happens. But last time, do you remember that there was a reflection going on from the stuff on the bottom had to reflect up? This time, it's a reflection, and it's going to reflect, the stuff that's on the right reflects over to the left. approximately like that. So there's my final answer in red. The stuff on the right all stays the same. The stuff on the left is a reflection of the stuff on the right. Now, that may not make sense to you right this second, but you need to at least write down an example for yourself. But I'm going to try it one more time to explain why that happens. I just did this green one here, and I absolute valued the x's. That meant all the negative x's had to disappear. And that's what this white box did, is it covered up the part of the function that was where the negative x's were, and they just disappeared. Now, the reason that it ends up reflecting the stuff on the right, let's say I had put in a 2 into this blue function, the original blue function. If I'd put in x is 2, do you get that it would give me that spot right there? What happens if I do the absolute value of it, and I used to have a negative 2, and I stick in a negative 2 into it, and when it gets absolute valuetized, it's going to make it just like I had put in a positive 2. That's why the stuff on the right needs to reflect over here, because if I had put in negative 2, which is what this really is over here, it's going to first do absolute value of it, turn it into a positive 2, and then it's going to act just like you put in positive 2. And therefore, it'll give the same response, which is to go down 2. So that's why you end up with a spot over here. If that doesn't work for you, just remember, in both cases, you wipe out a whole area, and then you do a reflection. Okay? So now, I'm going to go through this one more time from the top with a different shape, and you see if you can do it yourself without. Alright, so here is my new shape that I'll make in blue here. Let's do this side as a. I missed. I'm going to try again. And then let's go. There. Now, give it your best shot to tell me what the answer to the black one is. Undo. The black one, the f of x, this guy, where it's absolute valuing of the whole thing, and the green one, where it's absolute valuing just the x. One of them wipes out the y's that are negative. One of them wipes out the x's that were negative. Got a bunch of things. But have you got that too? Good. All right. The black one. First part is it's absolute valuing the y's. Why the y's? Because it's the f of x, and f of x is like y. It's absolute valuing all the y's. So that means I got to take my little white box here and get rid of all the y's that are negative. I got to read order to front. And there's me cutting out all the y's that were negative. Does that make sense? Now there's got a reflection go on. I can't bring stuff down there because I can't have y's that are negative. It's absolute valuing it. The whole function's being absolute valued. That means the only thing that can come out of this thing is positive things. So the stuff has to go up. So the stuff that was down there now has to go up. And it's like that. I'll block that out to make it more clear. There we go. The black one. Raise your hand if you had that right. Awesome. Okay. Next one is the green one. That's absolute valuing the x's. So I got to go over here and block out all the things that are box a little bit bigger. So I'm blocking out all my things where x was negative. Now this one has to have a reflection go on. But this time the function can be negative. See, there's not absolute values around the whole thing. The function can be negative. So That's where this one just reflects over this way. I may not be perfect because I don't have my lines, but it looks kind of like a McDonald's M, sort of. Raise your hand if you had that one right. Okay, good. Make sure you remember that. Now, you're going to see it on your review sheet today, the homework, and it's probably the most asked question. All right. Now, here's your review sheet. I'm going to hand it out way earlier than normal, and we're going to do something different than normal. I am going to ask you to do 4 of the problems in class like a quiz, and then we'll have another person grade it for you so that you'll feel like you just took the test, and we'll see how you did, and you'll have a more honest assessment of, are you really getting this or not? Okay, so we're going to do 4 of these questions as your quiz. Mrs. S? Miss S? Do you have something in your hand that you want to put on my desk? No, right over there on the desk. All right, here are the 4 that I would like you to do. I would like you to do 1A, 1F, 2B, and you know what? I'm going to change that to 2A. Sorry. You still need to do 2B for your homework, but 2A, B was kind of messy. And the last one is 6. Those are the 4 that I want you to try right now. Act like it's a little, like the test just got given to you today, because in theory it was supposed to be today. But we got that 1-day extension, all right? And then you'll have a more realistic guide of, am I understanding this really or not? Okay, I just realized one more thing. Generally speaking, you guys are pretty bad at piecewise. You may think you're good at them, but I'm telling you, I got so many questions on this last hour, I know we should probably practice it a little bit. So what I'm going to do before we start our little quiz thing, I want to do number 5 with you. I'll do it with you to make sure you understand how to do piecewise first. Okay, problem number 5. Let's make sure you're okay with this piecewise thing, because again, you learned it while I had a sub here. Piecewise functions. That means it's by pieces, as in piecewise. Okay. Now, look at number 5 with me, and it's 2 functions that have to share, and they only are valid between the places where it says. So, like, we've got to do 2x plus 3 as one of my functions, and I got to do x squared minus 5. My best advice to you is don't even look at the domain thing to start with. I would graph both of them, totally. And it won't be right until you erase some of it, but graph both of them. So we're on number 5 now. Please only work on number 5 with me. Graph 2x plus 3. Well, that's just a line where you got a y-intercept of 3 and a slope of 2. You remember that? This is the y-intercept. That's the slope. So this is just a line that starts here at 3 and has a slope of 2. So it goes like this. If I keep it going, it'll be like that. Going a little further, it'll be like that. Further. And I just do the whole graph. There. Okay? The other one's just a parabola. It's been moved down 5. So I'm going to move down 5. 1, 2, 3, 4, 5. And then I'll make my normal parabola. Over 1, up 1. Over 1, up 1. Over 2, up 4. If you don't know how to do this part, you got to go back to your parent ones and memorize it. Over 3, up 9. Over 2, up 4. 3, up 9. There we go. Okay. Now I need to go back and say it can't be both of these functions all the time. Where is that top function really allowed? It's really allowed between -4 and 2. And the endpoints are going to be really important. So where's -4 and 2? That's basically between here, that's where -4 is, and 2. That's where 2 is. Okay, between the green lines, that's where it's the red function. So do you get that I need to now erase this black function in here? I don't need all these black functions in there because it's only the red function between -4 and 2. And what did I say was the most important point of this whole thing? If you forgot that, you should write it down right now. The end points are what's going to get you on this. The end points on my red line, are they both solid dots? No. One of them is a solid dot, that one. And the other one is not a solid dot. It's an open circle. If you don't have an open circle there, it will be marked wrong. You've got to get your endpoints right. Okay, the next part is, I have a parabola going on with this black one. It was going like this. It was curving up. There we go. Again, once again, I would have it marked wrong right now because of my endpoint. Do you get, I've got a situation where it would fail the vertical line test because it would touch twice. See what I mean? So I got to look at my domain on this other one and say, is it at 2? It's this one. It's this function. It's not this function. So it's got to be an empty spot. Now, I check my endpoints and make sure this thing passes the vertical line test, and it does. And that's it. There's your answer for number 5. Okay, did you follow me on that one? On number 6, the one we're actually going to grade, I would encourage you to graph all 3 functions completely with pencil so you can erase them. And then go back and erase the parts out you don't need. And then the last thing is check your endpoints, because that's where kids mess up. All right, so do those 4 problems I told you before, including number 6. Maybe you should do number 6 right now because we just got done showing you how to do it. And then we'll be back to grade those in a moment. And we are back again. Okay, the answers now. So 1A. 1A is a graph that basically ends up looking like this with a V shape kind of up there. Now, how do we know exactly? Well, you can check it by using the equation y equals, what was it again? 3, and then x plus 5, and then plus 4. And you make a little XY chart. I really encourage you to do this. It'll help a ton. And then I'll put in, looks like -4 might be kind of important, or -5. If I put in -5, that's like over here, then it looks like it's supposed to be going up. Let's see what happens. Put in -5 here. -5 plus 5 would make 0. 0 times 3 is 0, and add 4 makes 4. You get how -5, 4 has to be on their graph? So double check it right now. See if theirs goes to -5, 4. There should be a dot there. Okay. Next thing, let's try like -4. That'd be like over here. And it should be up a little bit higher. So put in a -4 here. -4 plus 1 is 5. And then 5 times 3 is 15. 15 plus 4 is 19. Let me see if I did that right. No, I didn't. That is 1. 1 times 3 is 3. 3 plus 4 makes 7. So there we go. -4 goes with 7. So check and see if the point -4, 7 is on there. Do you see how you can check and be sure you're right? Please do that. All right. How many just graded that and theirs was right? Okay, good. Let's move on. That was the easy one. Let's move on to 1F. Some points that would be on 1F, which looks like this, square root of -x minus 4. Basically, it's this shape, except it's been flipped this way and then moved down 4. So it looks something like that. Some points that would be on it would be XY chart, 0, -4, -1, -3, and -4, -2. Those would be all on their graph. All right, how could I know that? Because if I stick in a -4 right there, I'll have negative and -4, which makes 4. Square root of 4 is 2. 2 minus 4 makes -2. That's how I got that point. So -4, -2 would be like right there. Okay, moving on. Next one is 2b as in banana. And it's, oh, I changed it to 2a. You're right. 2a. Sorry. 2a was 1/2 g of x minus 6. Well, it looks to me like that squiggly shaped thing, which was like this in the first place, needs to go where? Well, 6 to the right, and it gets half as tall. Now, if I was picking which to do first, do you know which to do first? Start on the inside. What's that? 6 to the right. So I'm going to take mine and just go like this, kind of cheating because I got a smart board. I'm going to grab it and move it over 6 spots to the right. 1, 2, 3, 4, 5, 6. All right. Then I have to make it half as tall. So I take all the heights, like this height right here, and make it half as tall as it was. And then make this height half as tall as it was down below. And then make this thing go half as tall as it was, which is like to there. So the final answer, I'll draw in blue here, looks like this. Okay. Just 1 point. All right, and the last one is 6. Number 6 is the hard one. That's the piecewise one. And I have that one up here somewhere on a previous slide. I want to find it because it's hard to draw. There we go. Okay. This is the straight line part, the 1/2 x plus, no it's not. Wait. This is the absolute value part, sorry. I should do this absolute value of x minus 4. That's that one. This part of the graph is the 1/2 x plus 1. It touches 1 for the y-intercept and has a slope of 1/2. And then the third part, this is the parabola part. The parabola has been moved 1 to the right. Yep. But only go with half. If there's more than one part of it wrong, it's just wrong. Okay, give them a score out of 4 and hand it back. Yes. Okay, let me